No, read the question. Go on.
Differentiate the question.
Yeah, and the question is...
And the question is...
What?
What is this called? Square root.
Yeah, square root.
Square root 8.
Yeah, okay, so you square root x.
Multiply.
Yeah.
Minus 2e.
Yeah. Yeah, what's next? X? Yeah.
Yeah.
Okay, alright. Just this one?
Wait. No. Wrong question.
Okay, go on, try again.
The V.
Okay.
Wait a second. No, okay, I'm good at this.
Alright, you changed your mind. Okay, fine. So what's the next question then? That's better for me.
The chain rule.
Chain rule, okay.
Yeah. 1 over square root 1 over square root 8.
Oh, okay. 1 over square root 1 over square root x. Interesting. Alright, this is an interesting one. So, you could change this into 1 over square root x power minus a half, because that's 1 over square root. If you wanted to, you could change this into x minus a half.
That is the chain rule.
I know, you don't have to use the chain rule. So like you could use the chain rule here now. You have two choices. You can use the chain rule, or you can use rules of powers.
But this question is in the chain rule.
No, I know. But in maths, if there's another way to do it, you can do it that way. So like if you do the chain rule, it's minus a half x minus a half minus 3 over 2. So bring down the power, take 1 from the power, and multiply by the inside derivative, which would be minus x minus then 3 over 2 there. So that would be it. Although if you were to use the rules of powers, you realize that this could be simplified to x minus a quarter plus a quarter, because the powers multiply. And then you could say this would be a quarter x, a quarter minus 1 is minus 3/4. Now, it should be the answers are the same. So this should also simplify to this, which it does.
How did we get the minus 3 over
A quarter minus 1.
Why quarter minus 1?
Because differentiate, bring the power down, take 1 from the power. So minus a half times minus a half is a quarter. This one would be x 3 over 4, and this one here is x minus 3 over 2. 3/4 minus 6/4, isn't it 3/4 minus 6/4 is minus 3/4. Yeah, okay, so both using the chain rule and rules of powers give you the same answer in the end. Fair enough? Yeah. Which you probably prefer this way, right? Straightforward. Yeah.
So the exam says use the chain rule, can we do it?
Yeah. Do you know, when I think about it, I cannot think of any question in differentiation where they force a particular method with differentiation. However, in integration, there are questions that you can do 2 different ways, and they sometimes say which way to do it, which we'll see shortly. But when it comes to differentiation, you're pretty much free to do it whichever way you want. Okay, Fawn, what's your last question there? Bracket.
2 over e to
To x.
first.
X or 2x?
2x.
2x.
Uh,
Bracket.
oh, another bracket.
Another bracket.
1 over root.
Square root.
Cos x.
Yeah, go on. Is that it? Oh, good. So, you can change this into 2e minus 2x cos x minus a half. What rule do we need here? And chain. So, first we differentiate this, which is a chain rule. So that'd be minus 4e minus 2x cos x minus a half. And then we need to differentiate cos x minus a half. Well, look who showed up. What happened to you?
There is traffic jam so much. Although it's like 10 minutes from my house.
Really? Do you know what you should do? You should leave 10 minutes earlier.
No, I leave 10 minutes earlier from my house.
Yeah, that's what you should do in future. Yeah.
But still I'm late. I should
Then 10 minutes earlier than that.
10 minutes square.
And then if you get to school early, just go to the canteen and have breakfast. That's what I did, and it was delicious. Alright, derivative here, we need the chain rule. So we bring the power down, reduce by 1, and then multiply by the derivative of the inside, derivative of cross, is minus sign. So I'll write sin x here and change that minus to a plus. We don't have to simplify, but clearly you can do some basic simplifying, like we can cancel this with this, obviously. So I'll write the answer as minus 4e. Oh, and actually e2x can come out, so I'll do that. E minus 2x minus 4 cos minus a half x plus sin x cos minus 3 over 2x. Okay, I didn't even have to do that. So, okay? Yeah, alright, so we'll start the next lesson now.
Is it like hard compared to the exam or medium?
The same. Should I ask if you did any questions last night? Or would it break my heart if I ask?
You wouldn't break it that bad.
What does that mean? You did some? Which one or two? How many? 2? 1?
1, 2.
Okay.
Improving.
Well, it is an improvement on 0 of the previous night.
Yeah, improved.
Yes, I know, yeah.
Zero, now it's not zero.
Yes. Maybe we can improve it even more tonight. Who knows? We'll see. Right. So the next lesson is something called implicit derivative. Now let me give you an example. So what's the derivative of x squared, of course? 2x. So you might feel like, oh well, then obviously derivative of y squared is 2y, but actually it's not. And let me show you with an example why it's not. Okay, so let's imagine a simple example. Let's imagine y equals x squared. So what does y squared equal? X power 4. So what is the derivative of y squared here? 4x cubed. Notice that this is not 2y, because if it was 2y, I should have gotten 2x squared as my answer, but instead I got this. So my point I'm making is, again, it's not going to be as simple as this. Now, it's actually pretty simple, but not as simple as this. So let me show you. So here's the idea. You want to differentiate something like, let's say, y squared. But the problem is basically this. This is y, but the derivative is for variable x. This is basically the problem. Well, there's actually a little trick here to fix this. If you multiply by dy dy, that's like multiplying by 1. dy times dx is the same as dx times dy. So I can kind of swap these. And what I've done is I've fixed it. Now, this is with y. So what's the derivative here now? Well, then that is 2y. But we have an extra dy dx. So in other words, if you have something which is in respect to y, and you want the derivative, sorry, I shouldn't put the little dash there. You have something which is in respect to y, and you want the derivative of it. It's the derivative as normal, except you multiply the answer by dy over dx. That is the only extra thing you need to do. And this is called an implicit derivative. And I'll show you examples of why this is useful. Okay, so but this is the rule here. I only have you at 9 o'clock today, isn't it? Yeah. Yeah, only 2 hours at 9 o'clock. Yeah, it's a shame. Alright, can we have a look at some examples? Yeah. So, why is this useful? Well, let me give you an example of when it's not useful. So, for example, if I said to you, I don't know, something like 2x plus 3y plus 1 equals 0, and I want the derivative here. Well, no, let's not do that one. Let me do a real one. So let's say you have x squared plus y squared equals 1. Now, if we want the derivative, so before today's lesson, this would be the old way to do it. This is the old way to do it. You would have to say, well, y squared equals 1 minus x squared, y equals square root 1 minus x squared, y equals 1 minus x squared power a half, and then you would use the chain rule. dy dx equals a half, 1 minus x squared minus a half times minus 2x, and of course there's actually a plus or minus here. And that's not too bad. But if I gave you something like this, x squared plus xy plus y squared equals 1, now all of a sudden trying to get that y by itself is too difficult. This is where implicit derivative can help. So, let me show you how to do this implicitly. Can I scroll down? So, if you have x squared plus y squared equals 1, we differentiate everything. Derivative of x squared, 2x. Derivative of y squared, 2y, dy dx. This is the rule, because it's a y. Yeah? And then derivative of 1, 0. So here you get dy dx equals minus x over y, because I can take this over to the right and then divide by 2y. Yeah? Isn't that much easier? However, there is a small price that you pay. What's the price that you pay to do it this way? You know, everything has its price. What's the price you pay here for this method? Compare the... Oh no, there is a price to be paid. Compare this answer with the previous answer. So there is a price to be paid. What is the price?
Simplified.
Kinda, but more precisely what exactly? So tell me, what do you need to know to calculate dy dx here? You need to know the value of x, right?
Yeah.
What do you need to know to calculate dy dx here?
To calculate the value of y.
You need x and y. And that's the price you pay. The price you pay is, to calculate the y dx, you need to know both the x and the y value, whereas previously we only needed the x value. Okay? So if this was an exam question, they would have to also tell you the point, like 1, 0, for example. Now tell me, what would you think you would have to do if they only gave you the x? So if they said, okay, x equals 1, and you're like, uh-oh, I need to know the y as well. What could you do?
Sub it in the original.
Yeah, sub it into the original and then solve for y. And actually, that is pretty common in the exam.
How?
Yeah, so you put x as 1.
Yeah.
You got 1 plus y squared equals 1. And you solve for y. 0. Yeah.
And then I put the values of x and y here.
Yeah. Now actually that's a bad example because here y can't be 0. But we'll have a look at a more complicated example now. Okay? So this is our first example of an implicit derivative. So you might want to write that down. Ms. Sharif, do you not like these students?
Why?
Because you always sit so far away from them.
No, I was sitting there, but you put this.
Oh, okay, okay. So you thought, should I move closer or further away? It's okay, I don't blame you. I would do the same.
Why?
I'm only joking, you know I'm only joking. Where's my video? I want to see my
Today
video.
I have 4 hours break today.
Okay, okay.
4 hours. We don't have ESE.
Yeah.
So,
You send the video in 4 hours.
for sure.
For sure? Alright. Can we do a more difficult example? Yeah. Let's do one a bit trickier. X squared plus 2xy plus 2y squared equals 1. Okay, we'll do this one together. Yep. Right. What's the derivative of x squared? 2x. Now, what about this part? 2xy.
Product rule?
Very good, product rule. So, derivative of 2x is 2, and then the y is y, plus 2x, and then what's the derivative of y? 1
times
dy dx. 1 dy dx, so just dy dx. And then what's the derivative here?
4y.
4y times dy dx.
4y.
Dy dx equals 0. Okay, what's in common here?
dy dx.
Not in everything, in everything.
2.
2. So I have x plus y plus x dy dx plus 2y dy dx equals 0. X dy dx plus 2y dy dx, what's up? Equals minus x minus y. What can I factor on the left?
We take the common.
Which is dy dx,
And
x plus 2y, and then finally, last step,
you put this one, yeah. And
divide. Now, that is much easier than trying to find y here. It's not, and believe it or not, it's not impossible, but it's extremely difficult to separate the y by itself in this expression. But not impossible, but certainly much more difficult than this. Okay, so if we can write this one down. So this is a typical exam question now. You're happy with this? Did you study this before? You think you've seen this before?
yes.
You haven't? Adnan?
Maybe.
Okay. Quite interesting. Mishery, have you studied this before? Yeah. Okay. I'm going to give you one to try before I do more difficult examples. So I'll give you one like this. Can I scroll down? Yes. Yeah. I have a break today as well for 3 hours. I should start correcting the maths exams. That's what my break's going to be. No, it's not. I gave... wait, no, you're Roland. Yeah, Roland has the coursework 1 mark for maths.
Friday.
Yeah, no, Friday, but I'm thinking now. See, I'm considering double marking them, because if I'm going to be your teacher, maybe I should mark your coursework again.
No.
Just this.
No, trust me, you'd want me to.
Why?
Okay, go for it.
Yeah. No, because Roland was looking at my coursework yesterday that I corrected for the science students, and he's like, "Oh, you're a little bit more generous." So then I know, I was surprised by that too. Yeah, so he then said, "Oh, maybe I'll recorrect my students." So I'm looking at your exams going, maybe I should recorrect them. And I said, I don't know.
No, not all like.
How much do I like the engineers?
Go.
I don't know. We'll see. So if I don't have your maths coursework on Friday, it means I'm recorrecting them, which is good news for you. Okay? Because if the mark is lower when I recorrect it, then I won't use that mark and I'll just pretend I never recorrected it and just use Roland's mark. I know. Nobody. Who watches these things?
Oh, so weird.
We do.
I know you do. Yeah. Yeah. I really doubt there's someone in some office somewhere going through all my videos, because if there was, my views would be much higher. Because some of my videos...
It should be high.
It should be, but what you gonna do? What you gonna do?
I think this video will be deleted today.
Just, don't make this video go viral on Twitter or something. Okay, try this one here. X squared plus xy plus y squared equals 3. And I ask you to find dy dx when x is 1. And I also tell you that x and y are positives. Okay, see how you can do with this one.
Minus 1.
For dy dx?
Two answer, right?
Is there? I thought there should only be one answer because I said y. Positive.
No, one is negative, one is positive. Minus 2 and the values of 1. Yeah.
Yeah, probably good.
Let's have a look. Derivative, what is it? 2x plus, that's 2x plus y plus x dy dx plus 2y dy dx equals 0. Did you get that? And then you should get now dy dx equals minus 2x minus y over x plus 2y.
Yes.
Yeah. Now, we haven't got the y, we only have the x. The x is 1. So we'll put the 1 in here to get the y. So we get 1 plus y squared equals 3. So that means y squared plus y minus 2 equals 0. So what's that? Y plus 2,
And
y minus 1. So we only take this answer because I said the y is a positive. So we know that x is 1 and y is 1. What's wrong with 1? So that's minus 3 over 3, which is minus 1, which is what you said.
Yes.
And you too. What was the mistake? Oh, okay. Alright, now there's another thing I need to show you with implicit. Wait, you're engineering students. Okay, I don't need to show it to you. There's a question on the worksheet, question 1, which the only reason I put in question 1 on the worksheet was for the science students because of, well, it doesn't matter. So when you're looking at the worksheet, the first question is about circles. That's not for you, so you can skip that one. Okay, but there is something else I still need to show you. Yes?
I thought E equal 2 and E equal 1.
Say again?
E squared plus
E squared?
y
squared?
y minus 2 equal 0.
Yeah.
The answer is y equal 2 and y equal 1.
No, y equals minus 2 and y equals 1, I think. Maybe I'm wrong, let me check. Y equals 1 and minus 2. Dun dun dun! Right, can I go to the next example?
Yes.
Yeah. Now, this next one is actually a proof that is on the exam. And they come in different, there's different things they can ask you to prove or to find, but the method is the same. Okay, so I'll show you with one example, and then you can try it with another example.
Can I ask?
Yeah.
Could be a stupid question.
Yeah.
But why do like dy over, like we move the x and the 2y to the other side?
Yeah.
So we still have dy over dx plus dy over dx. Yeah?
I kind of skipped the steps here. So what I did was I took 2x and y to the right, then I factored out the dy dx and multiplied down. Yeah. Okay. So a typical proofy question in the exam is they ask you to find the derivative of something like this. Now you might think, oh, I know this, but you actually don't. You only know the derivative of tan x, which is 1 over cos squared. You actually don't know the derivative of tan inverse. Oh, but maybe you do.
We can do it like 1 over 10.
Oh goodness,
No.
definitely not. That is quite forbidden. It's not the same thing as 1 over tan. So the trick here is you put a tan on both sides. So you have tan y equals tan inverse x. Now you might say, well, what good was that? That's not exactly easier, but it is, because you know the derivative of tan y. What's the derivative of tan y? 1 over cos squared y dy dx. And derivative of x is 1. So you get dy dx equals cos squared y. But this is not acceptable because the answer must be an x. But it's easily fixed. What's the definition of tan? It's what over what? And the other one with the sides of the triangle? Opposite over adjacent. So this is a triangle with opposite of x and adjacent of 1. So let me just draw that up here. Opposite of x, adjacent of 1. What's the hypotenuse then?
Y. Square root 1 plus x squared.
1 plus x squared. You got that? And the y is here, because y is the angle. So what is cos y? What would be cosine here?
1 over root square root.
Square root 1 plus x squared. But if I square it,
1 plus x.
and this is the derivative of tan inverse. And this is actually a proof. The exam would ask you to do something like prove the derivative of tan inverse x is equal to 1 over 1 plus x squared. So we've just done that proof. So the key trick for these proofs is you try and take the thing you don't know to the other side and change it into something you do know by using an inverse, and then you use an implicit derivative, and then at the end you convert it back to the x. This is the standard sort of process for these. So I'll give you one like this to try, a little bit easier, but this is the general method. So if you want to write this down.
I still can't understand why cos squared y equal 1.
Yeah, from this triangle, cos y is this over this. So that's 1 over root 1 plus x squared. But it's cos squared, so that's gone. Yeah.
But why you can draw that?
Because tan in angle is equal to opposite over adjacent. Tan of an angle. So that means an angle is equal to tan inverse opposite over adjacent. So what's in here are the sides, and what's here is the angle. Make sense? Makes a little sense, I think. Make sense? Yes, no? No?
Yes. No, doesn't get that. That's it.
Make sense? No?
Yeah, given chosen by sec square y equal 1 plus tan square y and tan square y equal x. So sec square is equal 1 plus x square.
Oh, there are many ways to do this one. Yeah, this is just the way to do it for this lesson, because remember we haven't done sec yet. Don't worry, we will do it.
Easier.
Yeah,
Pythagoras.
Pythagoras.
No.
No?
A squared equal B squared plus C squared.
Yeah, Pythagoras.
Yeah,
Yeah.
all.
We remove the root because of the square and the cos square.
Yeah, that's right. Okay, can I give you one to try? Right, so I want you to differentiate y equals a power x, and the hint I give you is to use log base a to simplify it. Now, before you start, stop. You actually know the answer for a very special case. If, sorry, actually, you know what? I tell a lie. Not log base a, log base e. In other words, use natural log. Okay, you actually know what the derivative of ex is. What's the derivative of ex?
Yes.
It's ex. But you don't know what the derivative of ax is, where it's a different number instead of e. So my hint is to use natural log to try and change it into something maybe more familiar. Okay, see what you can do.
Log or ln.
Well, they're the same thing. Log base e and ln are the same thing. Yeah. Any luck? Got an answer? What you get?
Y in
Close, but not quite that. Half right. Any answers over here, guys?
So, 1 over y divided dx equals 8.
Yeah, so, okay, yeah, you need to get it, you need to get dy dx equals with x's only.
Okay.
Got an answer? No. Okay, I better do this one. So, what we do is we put log on both sides first. Okay, I think some people did that.
Yeah.
Then you have log y equals x log a. Or, to make it really clear, log y equals log a multiplied by x. Now, derivative of log y? 1 over y dy dx. Now, derivative of log ax.
1 over a.
Mm-hmm.
Oh, it's product, right?
Mm-hmm.
Then A is
Just log a. Because it's like 2x. It's 2. This is just a constant coefficient. This is just like a number. It's a number. Like 2x.
But why is not 1 over?
Because there's no x in it. It's a number.
Oh.
Yeah. So we have dy dx equals y log a. But what's y?
X.
Yeah, so ax log a is the answer. Nearly. Did a lot of people get caught out with the log a x part here? Yeah. What happened for you, Mashreef?
I didn't compare y to ax.
Yeah. Who are you Snapchatting? Not Snapchatting? WhatsApping? Skyping? MSNing? Twittering? Facebooking? It was WhatsApping? Okay. Got this one written down? Yeah. Okay, so, no, not yet.
No. And then y log a, so you put ax log a.
No. Yeah? Okay, can I scroll down? Yeah? So I want you to work on these for a few minutes. Yes? What?
Actually, I can't understand the XL and A.
Here.
Yeah.
This is a rule from
No. Down.
here. Here?
Yeah.
Okay. What's the derivative of this?
2.
What's the derivative of this?
P.
What's the derivative of this? Square root 2. What about this?
Ln 2 plus.
No plus. This is just like a constant. It's a number. Like this, and this. What? Okay, can I scroll down now? Yeah. There, I can still see you WhatsApping. You're not invisible. Do you know, like, if I can see this, I can still see this. You know? Students seem to think that the teachers don't notice this. You know? Which I don't know if I should mean students think teachers are very stupid or something, that they wouldn't notice. You'll never know what's happened. Now, I want you to work on these for a few minutes. So you have two choices. You can either work on the worksheet, but if you do work on the worksheet, you want to skip question 1. Or you can work on exam questions, but please note that that might be a little too hard because the exam questions for this are usually in section B. So I don't really recommend it as your first attempt. Maybe later tonight for homework, maybe you want to do that. But for right now, let's say 10 minutes maybe? Yeah, 10 minutes if you want to work on this then. Yes, work on this. So this is what it should look like when you're looking at a worksheet. You should be doing things like this. Right? But if you're doing things like this, I know you're not doing your maths.